Hello here. Today I start about design of bridge or bridge design example. Bridge is important for all nations. Now today bridge design is carried out government of Bangladesh, which is prepared JICA. Now load structure manual for single lane bridge or the design example of bridge. Uh, these are show the bridges. These are the piers. These are the girder actually of bridges. Now show the detailed design. Table of content consists of structure, RCC brake, of concrete bridge, structural design of RCC girder, structural design of PC plate girder bridge, substructure and foundation, model details, apartment wall design, wing wall design, pile cap design, structural design of pile cap. And now chapter 1, superstructure design. First of all, design of superstructure RCC deck of RCC girder bridge. The design example comprises of 5.35 meter wide deck with two girder arrangement. The span of girders 23.35 meters center to center back, and the overall girder length is 24 meter. 24 meter. The girder are spaced at 2.5 these directions. Girder are spaced both deck and girder. Both deck and girder concrete shall be of 28 base crushing cylinder strength, that means compressive strength of concrete FMC 25 MPa. Reinforcing steel shall be of yield strength FY equal to 4.3 MPa. And now this is the arrangement of bridge actually. These are the supporting element of bridge. These are the footway. This is the main carriageway of bridge. Thickness of slab 200 millimeter. Cross section of deck slab. And deck slab design procedure. First of all, deck slab and design procedure and reference manual ASSTO S2. Proceeded method of analysis, refined method of analysis, and empirical design. Geometric data and material properties. Slab thickness of deck 200 millimeter, thickness of WC, various thickness and length, and railing, girder, material properties. Actually, these are the railings. And structural analysis are first of all analysis of slab. These are the loads comes from self weight of slab and another self weight of slab and girder position, girder spacing loading diagram, and dead load, self weight of deck slab, first of calculation, and self weight of wiring house. And this is the simple supported beam, so positive moment W square by 8 and positive in W2. These are some live load. Live load should be calculated from as to specification, and positive moment due to live load because factor moment 1.25 factor moment, and this live load and deck overhang. These are the various portions of live load, pedestrian live load, lane load, kilonewton per meter lane load, self weight of WC, self weight of slab. Six similar procedure apply this one. And loading diagram, deck slab. Actually, deck slab is a overhanging constructions and side wall width, and line load, with distance between CL of rail post and use of girder, distance between center of girder and use of sidewalk, and now calculation of dead load. This dead load are calculated clearly, and negative moment due to dead load at obtaining this part is overhanging, so negative moment should come out, and this analysis done by stack pro and live load analysis. Negative moment due to live load and overhang part. Total factor moment for deck overhang strength 1. Now design moment. Positive for reinforcement should be calculated this way, so the similar way, and negative reinforcement. Finally, find out the cracking moments, temperature and shrinkage reinforcement should be calculated, and distribution reinforcement. Structural design of RCC girder. These are the structural design of RCC girder. And now the cross section of deck slab and geometric data. Another example. Material properties, calculation of centroid and moment of inertia of girder. Centroid and moment of, because centroid and moment of inertia are important, so insulation properties of girder. And long section, these are the long section of girder. Girder consisting of various types of long sections. And long section, live load distribution factor, dynamic allowance, impact loading, IM is consists of impact load, girder design detail, and calculation of weight, bending moment due to dead load. These are the simple calculation, and dead load shear force calculations for full girder, and bending moment due to lane load, bending moment due to lane load, shear force due to track load. These are the shear force due to track load, shear force due to lane load, bending moment for simplified conventional method of track load, summary of design moment, and shear factor, crack width calculations, BS method, and deflection for reinforcement calculation. And surface reinforcement, shear reinforcement, shear force diagram of girder, and nominal shear resistance calculations, calculation of beta and theta. This calculation is very simple for design purpose. Checking whether transverse reinforcement needed, checking minimum transverse reinforcement, maximum spacing of transverse reinforcement, structural design of PC girder, the design example demonstrates the design of 3 meter, 30 meter span pre-stressed concrete. 30 meter is huge span, so must be pre-stressed concrete, otherwise use steel truss element. For this example, 200 mm thick RCC deck slab, 50 mm wiring course are considered. This example illustrates detail the design of single lane exterior girders. The design is accomplished in according with the Astro LRFD bridge design specification 2007. These are the bridge cross sections. Data cast in place deck slab, precast girder, Pre-stressing strands. Stress limit for pre-stressing strands before transfer and after transfer. Surface limit. State after all losses. Modulus of elasticity. Non-pre-stressing reinforcement. Section property. Non-composite section and mid-span. Normal density concrete. Modulus of elasticity. Modulus of elasticity for cast in place slab. Because girder at transfer. Girder at surface load. Non-composite mid and unit sections. Calculation for effective flange width. Effective flange width of exterior girder shall be taken as half of the girder spacing plus the laser of composite section at its mid-span, and calculation for exterior girder dead load moment, dead load total moments. Simplified lever rule, live load factor for exterior girder, dynamic allowance, and calculation of live load moment for exterior girder, moment due to track load, and moment due to lane load. So track load and lane load two are most important load for design of girder. Calculation of shear force and exterior girder, shear force due to track load, shear force due to lane load, total service dead load shear, calculation of losses, immediate losses, losses due to OS pull in and frictions, calculation of sag and radius of curvature, calculation of OS pull in the loss of frictions, calculation of loss pre-stress due to elastic shortening, elastic gain due to deck and other loads acting on the non-composite sections, determine long-term losses, creep and shrink-rest parameters. Just input this creep and shrink-rest parameter, loss due to shrink-rest of girder of concrete and loss due to creep girder of concrete, loss due to extension of tendons due to shrinkage of deck. Summary of post-tension losses. These are the summary: elastic shortening or gain, shrinkage of girder concrete, relaxation of tendon, creep of girder concrete, schedule of stress of girder at mid-span. And now calculation of moment capacity. Assuming rectangular behavior, non-pre-stress reinforcement, calculation of shear reinforcement, calculation of B and theta, calculation of pre-stress force components, calculation of deflections is the major parameter of design of wall structures, design of pin block, cable profile details, cable profile ordinates. And now chapter 2, structures and foundations. So chapter 1 is the importance of design of plate girder. Okay, thank you very much for watching my video, and